This is a simple fluid pressure example problem. I actually worked it earlier in a lecture, but it was kind of buried in the lecture. And this one I'm going to do as a standalone as part of our exam 4 review. The value of this example is that I use all three methods. I use FR as the resultant of the pressure distribution. I use the FR is equal to gamma Z bar A equation. And I use the horizontal and vertical method, all in the same problem, just to illustrate that all three methods give you the same answer. This is a slanted dam. The face of the dam is slanted 30 degrees from vertical. The dam itself is 20 foot high. The face of the dam is length L. And if you L cosine 30 is equal to 20, and so L is 20 over cosine 30, which is 23.1 feet, 23.1. We're going to find the resultant force three different ways. The first way is just the volume of the pressure distribution. And so you sketch a picture of the pressure distribution. So the pressure at this depth is 20 feet depth times gamma is the pressure there. You have a triangular pressure distribution, which is zero at the top, because that's a free surface, and you have a triangle. And the leg of this triangle is L, which is 23.1 or 23.09 feet. So the volume of this triangular pressure distribution is 1/2 base times height times the width in the board. So 1/2, the base is the pressure, which is 20 gamma. The height is L, which is 23.09, times 10 feet into the board. Our gamma is 62.4 pounds per cubic foot, so it's fresh water. And we get FR as 144.1 kip, or 144.1 thousand pounds. And again, it's perpendicular to the wall, which is 30 degrees from horizontal. And it acts a third of the way up from B. So 1/3 of 23.1 is 7.7 feet up from B, is where FR acts. The second method we'll use is the horizontal and vertical method, or some people call it the composite method. And so we've got this slanted dam here, and we can say that F resultant is equal to a horizontal force plus a vertical. The horizontal is the resultant of this triangle that acts on the vertical projection of this face. So the length of this triangle is 20. The pressure here is 20 gamma because its depth is 20. And then, of course, you've got the width in the page. So the F horizontal is 1/2 of base times height. So 1/2, 20 gamma. The height is 20, 10 foot into the page. And so our F horizontal is 124.8 kip. The F vertical is the weight of the fluid above the surface. And so this triangle here is 20 high, but this distance is 23.09 sine of 30, which is 11.55 feet. So the F vertical is 1/2, 11.55 times 20 times the depth into the page, which is 10, times gamma, which is 62.4, and we get 72.1 kip down. The magnitude of FR is the norm of these guys, and you get 144.1 kip, just like we got earlier. And this is FR as a vector, 124.8 I in the horizontal direction, minus 72.1 J in the Y direction. And it's basically the same as we got from the triangle. The third method is using the gamma Z bar A formula. So FR is equal to gamma. Z bar is the depth to the center of the plate. We said that this plate is like 23.09 long, but the depth is 20. So half of that depth is 10. So Z bar is 10. Area of this plate is 23.09 times 10 into the board. So my FR is gamma times Z bar, which is 10, times the area, which is 23.09 times 10. And that's, so FR is 144.1 kip. Now remember, FR, we found it from Z bar, but FR doesn't act at Z bar because this pressure distribution increases with depth. The FR is going to act lower than the halfway point of this plate. And in fact, it's going to act a third of the way up on this plate, which is 1/3 of the 23.09. So one of the unique, interesting features of this FR is equal to gamma Z bar A formula is that we use the centroid or the midpoint for the Z bar to calculate FR, but FR doesn't act there. It always acts below that point. So don't be confused by that. I sometimes call this the Giza formula or the Gaza formula because this is the Greek letter gamma, which is G in the Greek alphabet. So G, Z, A. So sometimes I call it again Giza or Gaza. It is a way of remembering it anyway, but it's gamma, Z bar, A. So all three of these methods are valid. You should know all three. But basically on an exam, use the one that works for you, the one that you can see. You might use one and then check it with another if you have time. And so all three are perfectly valid methods for this problem.